happens when you research how to mitigate a certain cyber attack and all the sources you find are wrong? What would cause that, and what's the right answer? Cross-site request forgery or CSRF attacks are a well-known web-based attack. When you Google how to mitigate a CSRF attack, the same answer always pops up everywhere: CSRF tokens. Now this video is my salacious, slanderous, scandalous hit piece of CSRF tokens. Not only do you likely not need them, if you implement them, you may introduce more bugs, increase complexity and scope, and just ruin the developer experience, and you might die. Well, I don't know. And you'll have more usability problems. And this warning isn't even mine. It's that of leading research groups like OWASP. You may even see videos next to this one claiming that you need them in order to be secure. I'm going to explain why they are wrong with receipts, and how avoiding the CSRF token pitfall can save you or your company time, money, and effort. So let's do a quick recap. OWASP says that a cross-site request forgery is an attack that forces an end user to execute unwanted actions on a web application in which they're currently authenticated. By default, browsers only permit sending a user's cookie along with a request when it's of the same origin. Origin being the same port, host, protocol. So let's look at an example. Suppose that I'm trying to hack you. I want to hack your bank account so I can pretend to be you and send your money to my bank account. Let's say you log on to bank.com. That might look like submitting a username and password and then receiving a session ID, and then that session ID being stored by the browser in the cookie that's designated for bank.com. As a hacker, I want that session ID. With it, I can make requests to your bank's API and move money around, like into my wallet. Here's what I tried. Let's say I somehow tricked you into going to some malicious website that I made called evil.com. And upon doing that, your browser, with all of its precious cookies that I want, receives all this malicious JavaScript that I wrote from my website, and your browser runs it. My plan is to have JavaScript take your bank.com cookie and send it to my evil server so I can grab it and do evil stuff. I can give your browser any code that I want. The cookie I want is in your browser. Can my evil code access it? No. Despite my best hacker efforts, I can't. The browser forbids it. Why? Because evil.com and bank.com are different origins according to the browser's same site origin policy. So the browser sees that the JavaScript from my website comes from evil.com, and the cookie from your bank comes from bank.com. Bank.com and evil.com, they're different. They're different origins, and the browser knows that and says, nope. What a bummer for me. My plans as a hacker are ruined. So I hatch another plan. If the browser automatically sends the cookie for bank.com with requests that are sent to bank.com, because it's the same origin, why don't I make evil.com make a request to bank.com directly? I can trick you into making your browser make what looks like a legitimate request to move money to my bank account. You click a link, it takes you to evil.com. Evil.com makes a malicious but valid request to bank.com. Your browser sends the request along with the cookie, the request is authorized, and boom. I took your money and I celebrate with honey chipotle chicken crispers from Chili's. I forged a request across a different site without your knowledge, hence cross-site request forgery. So the answer that we always hear about how to mitigate these CSRF attacks is CSRF tokens. CSRF tokens are meant to prevent CSRF attacks. Some people call them anti-CSRF tokens, and to those people I'd want to know if they call bug spray anti-bug spray, I don't know, but I'll call them CSRF tokens. This is simply a server-issued token that the client sends along with its request to ensure that the request was made on purpose from a trusted client. Malicious sites don't know this token, so while the evil site can send requests with your cookie to bank.com, they can't send the CSRF token. This way the server knows not to act upon the request. You might be wondering, isn't that what the session ID in the cookie does? Isn't that how bank.com is authenticating me in the first place? And yes, they are very similar, but the key difference here is that the token doesn't get included in the cookie, meaning the browser doesn't send it automatically. The client must be aware of it and include it in some place like the body of the request. In the bank.com example, this means that evil.com can make a request and the cookie will be sent automatically, But evil.com doesn't know what the CSRF token is, and the request is rejected. You can think of it as the session ID held in the cookie authorizes the user, and the CSRF token authorizes the request itself. While CSRF tokens and session IDs are different, your system needs to marry them so that only the right user can use the tokens meant for them. Historically and generally speaking, CSRF tokens have proven effective in the war against CSRF attacks. Before I address a better way, let's talk about the cons when it comes to CSRF tokens. Number one, it ain't cheap, especially for large enterprises. You're essentially building a pseudo authentication service on top of the one that you already have. Although CSRF tokens and the existing authentication system are different, they do need to be aware of one another, meaning the correct CSRF tokens need to be tied to the right session IDs. Number two is dev experience. You know how it is tinkering with Postman or something similar, poking at web services for development. It can be annoying to deal with identity when developing endpoints. Needing a proper way to get a session ID along with a CSRF token for each request can be a pain. Number three is a scary amount of implementation gotchas. If that CSRF token isn't in the cookie, then where does it go? In memory? In the DOM meta tag? What if they refresh the page? What if they have multiple tabs open? What if they click the back button? These gotchas are mentioned by OWASP, and they say that CSRF tokens, quote, may result in usability concerns and can be tricky to implement and degrade usability. So what is the better way? So let me take you back to 2014, which I know in web dev world is like 87 human years, and let me tell you a story. So, the secret sacred high council of our web dev religion called W3C made the official spec recommendation to browsers to make the cross-origin resource sharing mechanism. This monster became known as CORS. It was let loose to torment devs everywhere. This monster has a lot of lore, and it's very misunderstood. I'll probably save that for another video, but there's a lot to CORS, but I'll be focusing on what is relevant to CSRF at risk of oversimplifying. Basically, with CORS came the pre-flight mechanism. When your browser makes an AJAX request to another server that's of a different origin, that request can fall into one of two categories, simple or pre-flighted. A pre-flighted request means that before the browser makes the AJAX request that your code told it to do, it will automatically send an options request to suss out the server and make sure that your request will not violate any CORS policies established by the server, if any CORS policies exist at all. This pre-flight request will typically stop CSRF attacks in its tracks when servers have CORS configured properly. This is because the options call, that is the precursor to the real call, is essentially telling the server that it is of a different origin and checking if that would comply with its CORS policies. If it does, the intended request is sent normally. If it doesn't comply with the server-defined policies, or if the server has no CORS policies, the browser will not send the real request at all. A simple request, on the other hand, has no options call that goes out beforehand. The intended request is sent no matter what. This is where CSRF attacks can strike. So, what is the criteria for a request to be simple or pre-flighted? According to the MDN web docs, a simple request meets all the following criteria. We're just going to look at the method and header right now. Its method is either get, head, or post, and these are the only headers allowed to be manually set. And the content type is either form URL encoded, form data, or plain text. In general, a lot of modern web applications will usually have their data structured in JSON when it's in transit between the client and server. So it is likely that cross-site requests are already being pre-flighted, maybe without you even knowing. So modern apps should leverage modern mechanisms to deal with legacy vulnerabilities. So with all that said, here's a more modern and better answer for CSRF mitigation. All right, you ready? Okay, write this down. Here it comes. Make your server assert that incoming requests aren't simple. Boom. So that's it right there. So let's break that down to see what that would look like in our bank.com hacking example. Let's say that bank.com uses a REST API where it expects JSON content from incoming requests in order to trigger money transactions. If the engineers had a check at the controller layer of the web server for the content type being application JSON, that means that we know that the browser marked that request as pre-flighted, and we can have a high level of confidence that the request is genuine and not a CSRF attack. This mitigation will likely be trivial to add, and many web service frameworks have easy ways to do it. It might be as trivial as a one-line code change to assert that those headers are there. After the bank.com engineers put that mitigation in place, when you go to evil.com, my JavaScript doesn't add that header and the request will be denied. So let's say that I, the scary hacker, realize that change happened and I go, all right, nice try, and I change my client-side code to make nefarious requests to include the required header. Content type is application JSON. Then the browser now considers this request as a non-simple request. So the browser pre-flights this request, sees that my CORS policy disallows other hosts, or maybe that I don't have any CORS policies, and prevents my malicious call from being made. I'm SOL, and there's no honey chipotle chicken crispers for me. I really want to drive home how stupid simple this is, so let me break it down one more time. The key is to make your server assert that incoming requests aren't simple. Any header that isn't on this list makes the browser pre-flight cross-origin requests. Any header that isn't on this list. If my client code sends HTTP requests with a header called chicken crispers with the value of honey chipotle, and my server asserts that incoming requests have that header, then I can have the confidence that the browsers sending those requests have pre-flighted them, and I know that they're of a permitted origin. This method of mitigation is tried and true, and OWASP recommends this as a cheaper and safer solution than tokens in the CSRF cheat sheet. Industry-recognized data fetching tools like GraphQL that deal with browser-to-server requests a lot call out that they don't sweat CSRF attacks because of the assertion of headers that are required by pre-flighted calls. So you may be thinking, if pre-flighted requests kind of fix this, then why do simple requests even exist? And that's a pretty good question. So like a lot of security gotchas, this one exists to not break older tech that is still being used today. The form element in HTML has historically allowed the sending of data to servers of other origins. The form tag predates CORS, along with modern ways to fetch stuff like the XML HTTP request or the CORS-aware fetch function that's a little more recent. The general assumption is that these older web apps that predate all the CORS stuff had to figure out a way to mitigate their CSRF attacks in their own way. They did this without CORS, and they probably did it with CSRF tokens. So based on all the docs from MDN and OWASP and our examples, the form tag seems sketchy and seems to be an accomplice in the CSRF attacks. So are form tags even safe? The reason they historically haven't been safe and have been sketchy is because of their built-in form submittal action, like this, with the action attribute pointing to a file. When these vanilla forms are submitted through their default action with the action attribute, the dreaded simple request is made and the cookies go along with it. But it's important to note that a lot of modern web applications rely on JSON for communication between the client and the server, and they use JavaScript to submit these requests with forms, doing something like this, preventing the form default action and sending the data with JavaScript. There are a dozen libraries that handle this for you, like Redux Form, jQuery, React Hooks Form, and if you like bad apps, Formic. So while a lot of modern web apps don't use the native vanilla form submittal thing, they continue to use form tags for semantic and accessibility reasons. So form tags aren't inherently bad, but when you rely on their default form action to submit your data, that's when your sketch meter should go up, and that's when you should be aware that CSRF attacks can happen. OWASP recommends using CSRF tokens in this case because of that risk when forms submit data. However, I would still encourage the use of custom headers. Modifying the forms to send requests via JavaScript with custom headers is still probably cheaper than implementing an entire CSRF token infrastructure with a database and web service to partition the new tokens. There are other steps you can take to accomplish a more defense in-depth approach, a big one being ensuring that you consider the right same-site attribute for your cookie when you create it. The correct same-site type, preferably strict or lax, with the custom header approach is a home run mitigation for CSRF attacks. So in summary, use a custom header in your requests and make sure your server asserts that the custom header is there. And I'm going to make sure my server asserts that they're bringing me honey chipotle chicken crispers. Am I right? All right. Okay. All right. Consider subbing if you want. Later.